Hello and welcome everybody. So today is the day 2 of our Smart 25 Days challenge. So today we would be making a simple storage contract, and for that let us just move on to our Remix IDE. As I have told you earlier also yesterday, uh, you just need to click on these contracts and then click on create a new file, and we'll name it as simple storage. Oh, so good. So, uh, I guess you all must be remembering that I have told you that the first line is the SPDX license identifier. This is a basic comment to specify the license we would be using with this and ID. And then we'll just write pragma, solidity, and version. So see, it already creates this line, generates this line. So yes, we can move on. Pragma, solidity, and now uh for the version. So first of all, I would tell you about this line specifically. I have told you yesterday also, but today I have mentioned this in the notes as well. So what does the pragma directive mean? Okay, in Solidity, a pragma directive that specifies the compiler version to be used for compilation of the smart contract code written in Solidity. Basically, it means कि this specifies the compiler version to be used for the compiler of the smart code. Okay, it is usually the first line of code in any Solidity file. Make sense? And then the pragma directives in Solidity is primarily used for two purposes. Generally, it's used for the version specification only, but it is also used for experimental features. And we don't need to go here as of now. We'll be going here after some days. Okay. So we may not require to go for using the experimental features, but it is there that we can use them, okay, by using the pragma directive, by specifying the pragma directive. This is the use of this line, okay. And now let us move on to our code, and here we'll write contract, okay, to specify that we are writing a contract, simple storage, okay. So what we are going to do is create a simple getter and setter function. So yesterday I have showed you about a setter function. Today we will also see what is a getter function, what is a getter function and how we can use it. Okay. So in today we would be storing, creating a getter and setter function for a simple integer, and we would be setting its value and getting its value by using those functions. So I have told you yesterday also that we can specify C. I have told you yesterday what are the different visibility modifiers. Okay, so we can set a state variable as public, private, internal, or external. Okay, so yesterday we have seen what is a public state variable and how we can use it. So today we would be using a private state variable to see how it works. Okay, so we will use uint to specify that we would be working with a uint stored data. Okay, and that's all. So you in 256, what does this mean? You may ask, what is it? Okay, so basically it is a data type in Solidity. And what does a uint mean is an unsigned integer. Unsigned integer means that it would be only taking the positive values, not the negative values. And what does this 256 mean? 256 here specifies the number of bits that can be used. So I have written it in the notes also. You can see it, day 2. Okay. So first of all, what are some of the data types used in Solidity? You can go through them. I would be providing the link to these notes and you can read them. And we would be using them in the later on days. But today we would be working with int types only. Okay, integers in which uint and ints are there. Int. So integer covers all the values from positive to negative, and uint basically means only positive values. What does uint 256 mean? In Solidity, uint 256 is an example of an unsigned integer data type with the size of 256 bits. Okay, let's break it down. So it means that there are 256 bits. Okay, so by using 256 bits means you can either write specify the bit to be 0 or 1. So it gives you a large range. Okay, so this 256, this uint specifies unsigned integer. It means that the variable can only store positive or zero values and cannot hold negative numbers. 256 is this specifies the number of bits used to represent the integer value. In this case, 250 is it is 256 bits, and the range you can see it is quite large. Okay, from 0 to 2 to the power 256 minus 1. So this is basically very simple. As if I say that you are having only 3 bits, okay. So what is the maximum number you can represent using those 3 bits? It's 2 to the power 3 minus 1. That is basically 7. Okay, like 0 and 1. You all must be knowing how these values are written in binary form, and this is the decimal representation of that very large number. Means or if all the bits are 1. So if all the bits are 1, then this is the largest number then that we can represent using a uint 256. Okay, so basically by specifying that the data type as uint 256, we have done a simple task to tell the compiler that we would be the data type of this stored data is uint 256. And now I have told you what is uint 256. Okay, what does this 256 mean? And you can even change it to 8, 16, or like this. I have also written it here also. Okay, you can change it to the value as you need. You may want to use only 8 bits, so you can use uint 8. Okay, so now let us move on further by uh, and one more thing to note here. Why is it a common practice in Solidity to use uint in rather than int? Okay, so in Solidity, as we would be moving forward, you would be noticing that most of the times we use only uint. Okay, not int variable type. And why is it so? Because of the following reasons. Okay, you can go through them. These are very basic and simple reasons that most of the times we deal with non-negative values, and they are gas efficient also, and it maintains the interoperability. Okay, so now let's get back to writing our code for this. And for this we would be now writing a function for getter and setter function, and let us call the setter function as set. You can call it anything you want. And in this set function we will specify the parameter. Okay, to Acha, one more thing that I would like to mention it here is, if you have not mentioned anything after uint, the by default Solidity takes it to be uint 256. Okay, so it is better if you specifically mention it, but even if you don't mention it, it takes it by default as uint 256 only. Okay, and then we will mention the parameter. This is the parameter for our setter function. And this I have told you earlier also. This is the visibility modifier. And now we would be defining our function, and that function is simple. That is stored data equals to very simple. So now we have completed our setter function. I guess this is quite simple, as I have told about setter function yesterday also. So I don't think there is much explanation needed here. It's very simple. And if you are not able to understand it, then you can go through my previous video, that was day one, Hello World Smart Contract. And now let us write the function, getter function for this. Now this is something new. Okay, let's call this get. Will not take any parameter, public view, and then returns, what it returns is a uint 56. Okay, and in this definition we'll write simple return okay. So now you guys must be having some questions, and even if you are not having, then I will explain it to you uh, from a very basic perspective. So first of all, this this keyword function is used to specify that we are writing a function. So this is the name of the function. This can be anything you want, like getter function also, if you want, but I prefer it to be get only. So it's let it remain as it is. And then public is the visibility. Okay, visibility operator I have told you yesterday also. You this different visibility modifiers. Okay, and after this is something new. What does this view mean? Okay, what is it, and what does it mean? So view is the uh, view is the function modifier or state modifier. Okay, okay, this it's so what are function modifiers or state modifiers in Solidity? In Solidity, function modifiers are keywords that can be used to modify the behavior of a function. They provide additional instructions or conditions that can affect how the function is executed. Function modifiers are placed before the function definition and can be used to restrict access, validate inputs, or modify the state. So it's clear in itself, but to be very clear, it these are function modifiers which specify how this function will behave. Okay, whether it will modify these two, this view and pure. These function modifiers do not they are only view and pure are only read only. Okay, so they do not modify the state of the state of the function or state of the contract. Okay, and this payable, they it can modify the state of the function in some cases, and we'll see it how. So I have written it here also. It's very clear. Okay, you can go through it. That the function does not modify the state variables and is typically used for functions that perform computations to compute information without altering the contract's data. These functions are considered read-only and do not make any changes to the contract's state. On the other hand, payable state modifier is used specifically for functions that can receive ether and may involve updating the contract's state. Okay, so we will see the use of payable and pure in the later days, in the upcoming days. But for today, we'll just see for the view for state modifier or function modifier. Okay, so function get public view returns. Returns means what it returns, and it returns the data type, like what it returns. It returns 256 uint 256 integer variable type, and that is stored data. So you must be knowing why I have written underscore here. It's a good practice to use underscore for taking the parameters. Okay, so for specifying that you are using temporary variables, and like you are for the parameters you can use underscore. It's a good practice to use underscore. Okay, and that is simply that, and we'll now compile it and see how it works. Now we'll deploy it. So it has been deployed. And now you can see we have got two functions, a setter function called set and a getter function for calling. So if I call it now, the value is 0 as of now. Let us set it to 10. Okay. So it will set the value of this state variable stored data to 10. Okay. Now, if you see, it is taking value. Okay. Value is a argument. Okay. Value 10 I have given, and it's asking for a parameter called value. And now when I have clicked on set, it has set the value, and now when I will click on get, it will show 10. Okay, it means that the value of the stored data variable has been changed to 10. Okay, and now you guys can ask or may ask ki yesterday when we have written a hello world contract, in that what we have done was to before this keyword before taking the parameter, we had used a keyword called memory. Okay, so why are we not using memory keyword here? Why is it so? So its reason is written here only when it is showing a error, and it is saying that the data location can only be specified for arrays, struct, or mapping types, but memory was given. So basically, what it means is in Solidity, see why does the set function does not specify the state modifier? Okay, state modifiers view are typically. Oh, one more thing. Why does the state modifier, this state set function, why does this set function, you may have noticed that this is also not specifying the state of the state, like not it's not saying anything like pure function, view function, or anything. So why is it so? Why is it not specifying the state modifier? So the state modifiers are typically specified when the function does not modify the contract's state variables in this in the case of pure and view, and in the case of payable, the state payable means key it is involving some transactions. It is involving the transaction of some ethers, and it may involve the changing of the state of state variables, but it may or may not involve. Okay, so it can be the case key it does not involve the changing of state variables, but it may also involve that. So these state variables, state modifiers, are specifically mentioned in the special use cases. Okay, they are not mentioned every time, and if it is not mentioned, it means that the function is modifying the state. Okay, if it's not explicitly mentioned, then it means ki it is modifying the state of the variables, the state of the contract or state. It is basically we can say it is updating the state variables, and state variables are those variables that get stored on the blockchain. Okay, so these this here stored data is a state variable, and if it's and for this, why is it not why I have not when I am mentioning it, mentioning the keyword memory, that because this is a temporary variable. Okay, because this variable value is a temporary variable parameter, and it is just it will take the value from the user, and it will store it, update the store data. Okay, so it as I have told you yesterday only, you may remember, memory and storage are two type of keywords, है ना? This storage variable is used when we want to store the data into the blockchain, and memory is when we don't want to store the data of that variable into the blockchain, and we can think of them like RAM for memory, and storage for SSD. The data once stored in SSD gets remains there, and for RAM, we can think of it like temporary memory only. Okay, as it remains there until and unless you do not close the program. the until and unless the function do not get executed. Once the function gets executed, it gets clear. And for more details, you can watch the previous video. And so here it is saying that for simple types, okay, for simple, why is it no store? Why is no storage location keyword like memory or storage being used here in the set function to store the parameter value? In Solidity, memory data location can only be specified for complex types, such as this is the important point to note that it can only be specified for complex data types. Okay. Therefore, when we explicitly specify the memory data location for a simple value type parameter like uint 256, it will result in a compilation error. And one more thing to note here is even if for the functions you do not mention like here it is not required at all, and but in most of the functions what happens is the parameters are just for the sake of the execution of the function, and we do not want to store the value of that parameter into the blockchain. We want that value to be stored in to update the value of the state variable, and we do not specifically want to store that the value of the parameter every time onto the blockchain. So the Solidity takes it by default as a it stores it in the into the memory only. Okay, so the default behavior is that the parameter will be stored in memory only. Okay, so I guess that's it for today. If you have any questions, I know these are some topics which we have not covered, and we will cover them one by one. But I have given them into the, I have written them into the notes because so that you may go through them and get a basic idea of them. And as we'll cover, as we'll move forward, I'll uh, take you back here and then show you how we are using these. Okay. So you don't need to get worried about them. We'll cover each and everything in detail. So you can see, and one more thing to note here is we can do one more thing. See, I have told you that for a public state variable, I have told you yesterday, if you remember, for a public state variable, we do not require a getter function. Okay, Solidity itself creates a, so we can first of all delete this and deploy it. Okay, so you can see for this, see, for a public state variable called stored data, the Solidity has itself created a getter function with the name of this data variable only. Okay, with the name of this state variable only called stored data, the Solidity has generated a getter function called stored data. See, and I can set it to be 10, and now you can see its value has been updated to 10. So this means this is just to show you today we have used getter and we have made this function as private to show you how we can create a getter and setter function and how we can use a private visibility modifier. Okay, and when we'll see it, so now, so we can do one more thing. We can take this as make this as public only and use a getter function. So what it will do is it will create two functions. Okay, but for this two functions would be created. One would be created by default for this as this is a public state variable, and one we are creating here. Okay, so when we'll compile it and then deploy it, you'll see that now we have two functions to get the value. Okay, so let us first try to get the value. See, both are showing it as 0 only, and now let us set it to 10. Okay, now it shows a tick mark, that means the value has been set to 10. And now when we click when we try to get the value of the stored data variable, we get it as 10. Okay, so you can see this get function has been created by us. We have created this function, and this stored data have been created by Solidity because this is a public state variable. And as we'll make it private, so then this stored data, this function will not be remaining here, will not remain here. Okay. So first we need to compile it again. Compile it again to see the change. Now see. Now we can see that the stored data function has now been vanished because this has been set to private. I guess this makes it clear, and we'll meet tomorrow. And till then, bye bye. And if you guys have any questions, then please ask them into the comment section, and I would be more than happy to resolve them. Thank you.